So yes, we are going to work on measure of position, and the first measure of position that we are studying here is called the z-score. And like the Chebyshev's theorem and empirical rule, they use the standard deviation. This one, z-score, also uses the standard deviation. So when we say one standard deviation above mean, one standard deviation below mean, two standard deviation above mean, two standard deviation below mean, that number, when we say certain number of standard deviation above or below the mean, that is the z-score. If I say I am two standard deviation above the mean, meaning of that is z equal to 2. So the definition for the z-score is, a z-score is a numerical measurement used in statistics of a values relationship to the mean of a group of values measured in terms of a standard deviation from the mean. So this will tell you how many standard deviation above or below the mean the data value is. And that is the z-score. So z-score measures the number of standard deviation of the data above or below the mean. And we use this formula to calculate the standard deviation, the z-score. Write this formula, z equal to x minus mean over standard deviation, x minus mean over standard deviation. If it is for sample, we use the first one. If it is for the population, we use the second one. So because it is the distance from the mean, the z-score for mean is 0, and the z-score for numbers more than mean is positive, and z-score for number less than mean is negative. So meaning of that is, if you draw the normal distribution, you can draw this. If you draw the normal distribution like this, so here in the middle you have the mean, then we go like mean plus 1 standard deviation. We go down mean minus 1 standard deviation, mean plus 2 standard deviation this side, and this side we go like mean minus 2 standard deviation, and so on. For each of these, so for the mean, the z-score is 0 because we are not adding any standard deviation and we are not subtracting any standard deviation, 0. Here we are adding 1, so z equal to 1. 1 standard deviation above the mean. This is 2 standard deviation above the mean, so z equal to 2. This one here is 1 standard deviation below the mean, so z equal to negative 1. This one here is 2 standard deviation below the mean, so z equal to negative 2. That's why we say here the z-score for mean is 0. For mean, the z-score is 0. Z-score for data values greater than mean is positive. So greater than mean, towards the right, you can see it's positive, positive 1, positive 2, and so on. And for the data values less than mean, you can see the z-scores are negative. Z equal to negative 1, z equal to negative 2, and so on. And we use z-score to compare the data values from two different series. So what is the meaning of that? We are going to explore with an example. Here is that example. Let's work on this. Let's find out what is given here. John scored 85 in his maths 135 quiz where the mean is 76 and his standard deviation is 4. So the first information is given. John scored 85 in math 135 quiz where the mean is 76 and his standard deviation is 4. Mean is 76. Maybe this is for sample. Mean is 76 and his standard deviation is 4. And that is his score, X. He also scored, that is the second set of data given here. He also scored 42 in English 122 quiz, where the mean is 36 and standard deviation is 3. So in English 122, this is the information about his quiz. He got 42. The mean was 36. It's moving, just a second here. Okay, mean is 36 and the standard deviation is 3. Now, what we are asked to do is we are asked to compare the relative position on the two quiz. Is the question clear to you? The, the question is asking you in which test, Math 135 or English 122, he did better. They have given the mean, standard deviation for both, and they have also given his score. Okay, so in order to find out in which exam he did better, we have to find the z-score for each. So the first thing is z-score for, let's do Math 135. Z-score for Math 135. If you want to find the z-score is x minus mean over the standard deviation. That is the formula. So x here is 85 for Math 135, minus mean is 76, divided by the standard deviation is 4. Please perform this calculation in your calculator. First, you have to subtract and divide the difference by 4. First, you have to do 85 minus 76. You should get 9 and divide that by 4, and you get 2.25. Is that what you get?
Yes.
Okay, that is the z-score in Math 135. Now let's find his z-score in English 122. So let's find out for English 122. Z-score for English 122, same formula, x minus mean over standard deviation. X is the score on the test or the quiz, it is 42, minus the mean, which is 36, divided by standard deviation is 3, which is equal to, first we have to subtract 42 minus 36, which is 6, and divide that by 3, and you get 2. You can see in both cases, in first case, this value x is more than mean, so z-score is positive. Also in the second, you can see the score in English 122 is also more than mean. That's why z-score is positive. Both z-scores are positive. But which one is more? Z-score in 135 is more, or z-score in English 122 is more? Which one is more? Tell me which one is more.
Math.
That's right. Z-score for Math 135 is more than in English 122. English 122. Meaning of that is, if the z-score is more, he's performing well on that. So here we are asked to compare the relative position on 2 quizzes and interpret it. So the relative position is he's already higher in Math 135. Meaning of that is, the interpretation for that is he performed well in Math 135 when compared with 122. So the result or the meaning of this is John performed better in Math 135 when compared with English 122. So we can use the z-score to compare the data values from 2 different sets. So if the z-score is more, that's a good relative position or better relative position. And if the z-score is more, meaning of that is, in that one, he's performing well. So here, z-score for 135 is greater than for English 122. So John performed better in Math 135 when compared with English 122. Any question on this one? No?
No.
Okay.